All right, let's give everyone just a few minutes to kind of drop on in here. Oh, that's much better. You're going, hey, what's this garbage gobbledygook on here? I can't tell what that is. Just a few moments and then we'll get things rocking and rolling. Okay. I think everything is just about ready to rock and roll. All right, well, let's get things started. Greetings, tech artists from around the world. It is Friday and it is 12:30, and that means it's time for another episode of Tech Art Talk Live. My name is Chris, and I am going to be your host for today's session. Now, last week we were continuing on all about HLSL and shader programming, which is really awesome. And this week we're going to continue on, and I promised you that I was going to talk about normal mapping and displacement mapping. Well, gang, I guess I lied. Well, because unforeseen things happened, and I have to admit, I failed you. And what happened was, I've been having this kind of love-hate relationship with ShaderEd, and I finally hit my max capacity frustration with ShaderEd, and I got to a point. I reached the tipping point where I said, no mas, and I just said, no more. I'm out of here. And so what I'm going to do is go back to my old favorite, which is a tool called Shader Toy. You're probably going, Shader Toy? What is that? It is a application that you can buy from a company called Byte the Bytes, and you can purchase it on Steam. In fact, that's how it is distributed, through Steam, and it's a good package. It's like $30, and I know it's a lot of money, but so far it's been like one of the best shader writing programs I've ever used, and I use it extensively. I use it at FIA to teach my shader programming, and the only regretful thing is that it's not free, and I just ended up pulling out too much hair with ShaderEd, so I'm going to have to go through the introduction about how to get things going with Shader Tool. Yes, no longer ShaderEd. So let's get this lecture started here. Okay, here. Demo here. Okay, let's get this going here. This is what Shader Tool looks like. We got a bunch of stuff here. You like Shader Ed, you could work in DirectX or OpenGL. We're going to be working in DirectX, which is, in other words, HLSL. So I'm going to go ahead and get things started here. I'm going to say click New. It's going to say enter a project name, and then I'm going to call this Demo Normal. And then I am going to save this inside of my TechArt EDU folder here. Okay, I'm going to save it right here for this week's lecture. Okay, and then call it Demo Normal. We'll click OK. And then you end up with just a grid like here. Now this grid is kind of like an open platform, where an open canvas where you can kind of like go ahead and create lots of things. It is kind of shader based, which means you could do some text writing, and it's node based, so you got a little bit of both. And we're going to start here by right clicking on here and click on effects, and then we're going to want to drop in an effect. Okay, this is where everything happens. So if we click on this, we'll click on the shader name, and I'm going to call this normal. Well, let's call this yeah, just call this normal mapping. All right, I'm going to click OK. And now notice here a little window pops up off to the side. Now this is the window at which we are going to actually create our shader with. And I'm going to put a little pound sign up here and say this is my normal map shader. Okay, now there's some different things that we have to worry about here that we didn't have to worry about Shader Ed, and actually some less things that we worry about when we're working with Shader Ed. So I'm going to go ahead and save this. Oh, it says this is, okay. Is it 4? Yeah, there it is. Got my languages mixed up, gang. Sorry about that. So it's ultimately, we're going to do the exact same shader that we worked off with last week when we were doing our blend Phong shading. But we're going to start from there. So we're going to start with that. We're going to look at here. Here is the common utility file that we created before. I'm going to call it common FXH. Now it has this pound define up here that kind of establishes and make sure that we don't declare it more than twice. But look at here. Here are constants where we call or define flip texture Y. Now in this situation in Shader Tool, the Shader Tool actually does flip the Y coordinates, so we're going to have to say yes on here. And then we've got here we get the get coordinate correct texture coordinates. This function here, this is actually going to do the flipping for us. And then we've got two other functions: get vector color contribution and get scalar color contribution. We're going to use these in conjunction with the lit function in order to get things driving. So I'm going to go ahead and save this as, and click on here, and we're going to call this Demo Normal. Click it in Effects, and then I'm going to store this in called common.fxh. All right. Now you do have to call it .fx because this is a little bit different. In Shader Ed, you called it HLSL. In this case, we're going to be calling these .fx files, and because this is a header file, this is not going to be actually part of the direct part of the shader itself. We're going to call it a .fxh file. Click here. All right, so let's take a look here. I've got the source for my code here. Let's go ahead and code right here. I'm going to copy this and then go back to Shader Tool. Here we go. I'm going to go ahead and just paste this right into here. Okay, gang. This is exactly the same stuff that we were dealing with last week when we were dealing with the pixel shader and the normal shader doing blend Phong rendering. It's the exact same stuff, but it's fewer. It's combining the two files. In Shader Ed, it had two different files, one for the Vertex Shader, one for the Pixel Shader. We're combining them both into one file, and you're going to see it makes things a lot easier. So here's our constants, and we have to have our C buffer per frame, and inside that we have our ambient color, our light direction, and our camera position. Notice here we also have a C buffer per object. That means for every one of these objects, we're going to have one of these C buffers. We're going to have its specular color and its specular power. All right, because we're dealing with one file here, we're only going to be dealing one set of texture structures. And in this case, we've got a Vertex Shader input, and what we want here is our object position, and we want our texture coordinates and our normal. Output, we want our position, our normal, our texture coordinate, our light direction, and our view direction. Now, we didn't have to deal with anything called a texture state when dealing with shader ed. Now, this is something that we're going to have to do, which is a little bit more traditional HLSL programming. We're going to have to create a little data structure called a rasterizer state. And so in this rasterizer state, we're going to call it disable culling. So ultimately, what we're going to be doing is we have a little open parentheses, we say cull mode equals none, a little bit closed parentheses, and followed by a semicolon. And so what this means is that when we're declaring this rasterizer state, that means we're going to we're not going to be culling anything out, which means is that the shader isn't going to be excluding any kind of back faces. It's just going to render everything. That's really all that it means. All right, we've got our texture 2D, which is our pointer to our texture map, and we're going to call this color texture. And here we have our sampler state. Now, once again, this was not done on this, and it could be override with the interface for shader tool, but here we're going to need to declare our sampler state. And so our color sampler has a filter with the min, mag, mip, all make that linear. And for the address u and the address me, we're going to make them all wrap. Now, as a review, here is our vertex shader. Now, inside the vertex shader, we're going to take our position, and then what we're going to do is multiply our object position, and we're going to multiply it by the world, view, and projection matrices. Okay, this is the code we took exactly from shader ed. And then we're going to have our texture coordinate, and then we're going to get our corrected texture coordinates from our in-texture. So in other words, none of this is really different and change. Our normal is we're going to transform our normal into world space, and then we're going to multiply our normal into world space. We're going to only take its x, y, and z components of the result of that, and then we're going to set it back to normal again. And then we're going to take our light direction, and then we're going to normalize the negative of our light direction. Okay, exact same stuff as before. Our world position is going to be our object position multiplied by the world matrix. And then we are going to subtract our world position from our camera position, and we're going to take the normal of that, and then we're going to assign that to our view direction. Okay. Nothing new here. That's basically the same. Let's take a look at our pixel shader. Inside of the pixel shader, we're going to receive our vertex shader output. Notice we don't have to worry about pixel shader input. We're just going to worry about our vertex shader output. Why? Because we're just dealing with one file, and we're going to double purpose this one existing data structure. We don't have to create anything new, which is actually really kind of convenient. Okay, what the first step we're going to do is we're going to normalize our input normal. Then we're going to normalize our light direction. We're going to normalize our view direction. Then what we're going to do is we're going to take the dot product of our light direction and our normal, and then we're going to take create our half vector. And the half vector again is the light direction plus the view direction. And then when we add those two, we're going to normalize that and kind of like give it a magnitude of 1. Then we're going to take the dot product of our normal and our half vector. Okay, very simple. We're going to grab our color sample from our texture map, and then here we're going to use the lit function. We're going to send the lit function. We're going to send our n.l value, our n.h value, and then are going to get our specular power, and this is going to return our lighting coefficients, and then we're going to get our ambient color from our regular color. We're going to get our diffuse color, and then we're going to get our specular color. And remember, the specular color is a little bit wonky, so what we're going to do is we're going to take our light coefficient, the z value, and then we're going to take its color the color W value, which was ever our light color is, or actually our specular color, our texture map color, I'm sorry, and then we're going to take the minimum of those two values. So we're always going to look for the darker thing, and this is going to make sure that our specular component colors along with the light. And then we are going to get it from the specular color, and that becomes our specular component. And then we're going to add the three: our ambient, our diffuse, and our specular color. And this is going to be our output, and we should be ready to go. Okay, there's one extra thing that we need to do. Now, Shader Red kind of took care of this, but because it's all going to be transferred into this, we have to create a technique. In this case, the technique is called basic here, and which is fine. In fact, we're going to call this, actually, we're going to change this over from basic. We're going to call this normal mapping. And this is the technique that we use. And we can bring in multiple passes for every one of our techniques, but we're going to leave this at pass 0. And so what we have to do is identify what our vertex shader is. And so in this case, we're going to call this as compile shader. Right here it says VS50. Okay, now this is a HLSL system variable, meaning we want Vertex Shader 5.0. This is a standard kind of like way of organizing the data, and we're going to send it Vertex Shader. This is like going to establish that we want this as our Vertex Shader, and then we set our geometry shader to null because we don't have a geometry shader. We'll go into that in a few weeks. Our pixel shader, we're going to do the exact same thing about setting it with compile shader, PS5_5. We're going to call that the pixel shader. And then we're going to say set our rasterizer state to the disable calling. I'm going to go ahead and save this. And okay, here's a problem. Here's one of the things that I don't like about Shader Tool is that it doesn't remember where the object is, so it's not reading in common FXX. How we know this? It says undeclared identifier world. We remember we set the world inside common.fxh, and that's not where things are going to go. So let's go and make sure, actually let's go ahead and define, let me make sure that we have this. So we have here and is, okay, so it's not there. It's actually in here. So what we're going to have to do is I'm going to create 3 matrices. Boom, matrix, and I'm going to go world, matrix, I'm going to call this the view matrix, and another matrix, and it's called the projection matrix. Okay, unexpected token matrix, line 5. Oh, I need a semicolon here. And we should be good. No, this is not spelled correctly. There we go. Okay, get corrected texture coordinates. Okay. Now it's not identifying where our function is, and the reason for that is that it doesn't remember that we are actually getting our stuff from common FXH. So what I'm going to do is I'm just going to make sure to save all of this. Then I'm going to exit out of this project, and then I'm going to go back into it, and notice here that all of our errors have gone away. Yay! And everything is copacetic. We are now rocking and rolling and ready to boogie woogie. All right, so now that we've got this here, let's go ahead and we've got to hook up all of our nodes in order to get things working. Whoops, that's not what I wanted. Okay, is that going to go? Yeah, that's going to go. And in other words, I want to move this over to here, and I want to take a look at my notes here. And hopefully we can look at the notes and still go on to there. Yeah, there we go. All right, great. And let me make sure that we're still looking at there. Okay, so everything should be good to go. All right, so here, this is our effect. And so what is the first thing we need inside of the shader pipeline is we need a draw call. And so I want to click onto here and go and click into the scene, and here is our draw call, which is this node here. And here, notice that this is just kind of a blank. This is actually the think tank. This is actually the guts. This is actually the shader engine itself here. And you're going, really? That's all that it is? And I'll say, yeah, but there's a lot of magic inside of this node. So what I'm going to do is I'm going to hook up my shader to this, and notice that it's taken on a whole new life. All of those variables that we had input to it and now become inputs to our box here, and then we have a little output right here. Now this output is going to be where our texture buffer or the image buffer is going to come from. And so what we're going to do is we're going to create a render target. And so this is where the information from our rendering engine is going to get targeted here. Now we're going to use this again when we go into visual effects, because instead of because we're going to be using render targets in order to create visual effects with. Okay, we need something to render. And so what I'm going to do is I'm going to drop down here. This is a primitive, and I'm going to drop down drop this in here, and I want a sphere instead. Okay, let's get a sphere. All right, now let's start filling in all of these variable inputs we have here. So we need a world matrix. Okay, now I could go through and create some translations, some rotations, and some scales, but I'm going to keep this easier. So all I'm going to do is grab a simple rotation, and they got a simple rotation matrix, and that's going to come right in here. I'm going to drop that right into here. And now we have to go for our view and our projection. This sounds like camera stuff. So what I'm going to do is I'm going to down and put a camera into the scene here. Okay, we got the camera in here. I'm going to hook up my view to the view node and projection to the projection node. And my position, we're going to move that into the camera position. All right. Hopefully everybody are following along. Now we need our three colors. We need three colors to work with. We need our ambient color, we need our regular light color, and we need our specular color. So I'm going to right click here and types, and I'm going to grow a color here, and I'm going to grab three colors here. I'm going to grab this, and we've got one for our normal color, and we've got one for our specular color. And so for our ambient color, I'm just going to keep that at 0.1, 0.1, 0.1, and then make sure that that value is 1. Now for our regular light color, I'm just going to make it white light. And I'm going to move my values all over to 1. And then for our specular light, oh, I'm going to make it kind of like I want to make it frickin' red. Yeah, that's it. And don't forget to put that alpha up to here. And so let's hook these up into the spots. Let's hook this up into the ambient color. Here's the light color. And then here is our specular color. Okay, we're almost getting there. We need a light direction. So where is our light coming from? Okay, our light direction is going to be coming from, this is our light position. And so what we're going to put here is just a simple, we want its location. So I think we want here is 0, 0, let's see, -1. And this is going to come from our light direction. And then our specular power. And remember, for the specular power, we want something between a value of 10 and about 50. So I'm going to put my range in here, 10 and 50. And then I'm going to drag that right over here into the specular power. And we're going to give this some go-go juice. Okay. And now we don't have anything going here. Now we should have seen a rendered image. Okay. Now, I do not know why we don't see anything. Where's my... And then do we have our technique set? Normal mapping? And... okay, we do not have everything. I imagine you go through, this is the problem with live demo, folks. You can go over this a million times, but it never actually works the way you want it to. Okay, so let me actually see if, let me save this and then open this. Do we want to save this? Yes, we do. And normal diffuse, pre-normal mapping. And let's see if we got here. And this is our normal mapping project. And yeah, this is all kakamaka and nonsense. Okay. And so I do not know. Oh, let's go back to where it is, demo normal. Okay, so why don't we have a render target here? So I'm going to delete this, and then I'm going to get a render target here. And we're still not getting anything. It's always worrisome whenever we don't see anything showing up at first. Don't know why. And let's see. Let's make sure we got this as a view, projection, and a light position. Let me see if I can create yet another draw call. We go to scene, and we need a draw call. Let's hook this up here, and here's our object, and then here's our world matrix, and our view coming in from here, the view matrix, world view projection, and then our ambient color is coming in from here, and then our light color is coming in from there, and then our light direction is coming in from here. Our camera position is coming in from here. Specular color coming in from here. Specular color, specular power is coming in from here. Oh, here it is. I just realized this. I forgot to put in my color texture. That's no wonder I didn't show anything, because there's no texture coming in. So the texture value is coming in at 0, so that we were getting 0, zilch, 9, nunca, nada, nothing. So let's go ahead and grab a texture. And so our scene, oh yeah, our content, we need a texture. And so let's get a texture in here. And so let's grab a good old evil eye texture, plug that in here, and there we go. Oh boy. Okay, so here we have is our light. Now notice, just like in Shader Ed, if we fold around here, we can look at the backside, and there's our backside, and we move around here, and then we can move our light around. If we move our light, oh that's right, we don't have a thing, but we can move the light around. So this is kind of like to be like a negative, -1, moves it over here. If we move it is to 1 over, move it over there, so we can move it around here. And if we wanted to actually put a slider there, we could put a slider on there and kind of move it around, but I think everyone gets the thing. So here we are, we've basically gotten to where we left off a week ago, and we've reproduced all the Shader Ed. Now let's talk about normal mapping. Thank you very much for your patience. Okay, normal mapping is definitely one of those critters that is a lot more difficult to explain than when have here, and let's get things back on the rack, or get back things to going back. Oh, I didn't want to do that. Get things back here. All right, good. Okay, so what do we got to do in order to get this thing going here? So we're going to start off here. We're going to go into our shader tool here, and this is the interesting part. We, in order for this normal mapping to work, the world and the view and the projection matrices have to be in the C buffer per frame construction. And the reason for that is because we want all of our views and projection being the same for what other object we put into the scene. Okay, so there we go. There we have it taken care of. And now what we have is the world matrix. Remember, the world matrix is coming along with the object itself. And so every object has its own world matrix. And so what we're going to do is put the world matrix into the C buffer per object because it's unique per object. Okay, now notice that nothing really changed. The change of order happened here inside of our inputs, but nothing else actually changed, so we are good to go. All right, now what we got to do is we got to add a new normal map. Okay, this is another texture. And so I'm going to go ahead and copy this. And so instead of our color texture, we're going to add here, and we're going to call this normal map. Okay, notice here we got a new input, and now it's looking for our normal map. So let's go ahead and give it a normal map before I forget and delay things any longer. So we're going to go to contents, we're going to go get a new texture, and let's grab a normal map, and let's grab our pillow, and I'm going to click onto here, and drag that into normal map. All right, we're good to go. Nothing happens because we haven't told it what to do with it. Oh, you know what? Just realized here that I don't necessarily want a sphere, because the sphere isn't going to look really good. It would look better if this was actually a plane. So I'm going to change my sphere over to a plane object, but it doesn't look like it's there. It's there, gang. You know, have no fear. So what I'm going to do is, remember how we put the world matrix and we assign that to every single object? So here is our world matrix, which is in a sense just the rotation, and I'm going to rotate our object. And so there's our object now rotated, so it's more or less perpendicular to us. All right, fantastic. Now let's go ahead, go back to our shader, and make some modifications to our data structure. All right, now we have the position, our normal, our texture coordinate coming in. Now all that we need, in addition to what we have here, and so what we have is our position, our texture coordinate, we got our normal, and then we have our position, our texture coordinate, our normal, and what we need is one more, is we need our tangent input. Now most of the times that tangent input comes along with all of the data. So missing my FL here. Okay, so we're going to be input our tangent, and now we're going to be doing the same to our output. But in addition to our tangent, we now need a binormal as well. And so we have our float 3 tangent and our float 3 binormal. Okay, now we are good to go. Let's go into the vertex shader. Now, the vertex shader is actually pretty simple, because all we have to do is normalize. We have to put our normal vector into world space, and we've already done that. I'm gonna copy this, and we're gonna do the exact same thing to our tangent vector. So I'm gonna change this to tangent, and then I'm gonna say in.tangent. Okay, everything is cool. Now all the thing we need is our binormal. And so I'm just going to do a cross product from our tangent to our normal, and that's going to create our binormal. There we go. Our binormal equals the cross product of our normal and our out dot tangent. Okay, now everything is cool. Okay, everything is going fine. Let's go ahead and make our modifications to the pixel shader. Now, there is a little bit of pre-processing. So what we have to do is we have to get our, we have to go and create our Tbn matrix. And then from our Tbn matrix, we're going to get our point position. And we're going to send that into, we're going to send our normal into Tbn space. And that's going to give us our new normal. So I'm going to first, we're going to sample our object from the texture, from the normal map. Okay, so it's a little bit longer. And so remember, what we're doing here is that we're not dealing with a colored anymore. So here it is, we've got our normal map. We're going to sample it with our in-texture coordinate. But then we're going to multiply it by 2 and then subtract 1 from it. In other words, what that's going to do is it's going to transform this color into a vector that's between -1 and 1. You're probably going, hey dude, something's problem with there. It's not going for that. It's going between -0.5 and 0.5. You know, that's okay, because what we are going to do is that we are going to, we're going to normalize it. And so here it is. So here we go. We're going normal. We're going to normalize in dot normal. And so we're just going to normalize our sample normal. And now it is between -1 and 1 space. Now, if we go ahead and execute this, it's going to look all funky. Oh, yeah. Okay. Undeclared sampled normal. Okay. I misspelled sampled. Okay. It looks black now. Okay. Because we just mucked up our normal map big time. So we have to go and fix it in order to get things working properly. So in order to do that, let's create our Tbn matrix. And to create the Tbn matrix, it's really simple. Because all we have to do is create a float 3x3, which is a 3x3 matrix. And then say Tbn equals float 3x3. For our top row, we're going to put our tangent vector. The middle row, we're going to put the binormal vector. And the lower row, we're going to put in the normal vector. And then we are going to sample our normal, and we're going to multiply it by the Tbn matrix and put it into Tbn space or into tangent space. So our sampled normal equals mul, the sampled normal, times Tbn. Okay, so now it's now been, the normal has now been jiggy-wiggied with in order, and now it's now positioned to correspond to the normal that came from our texture map. And then we got to make sure that it is now sampled, but we normalize it there. So if we go ahead and click save, there it is. Now, that's really all that there is. All that complication, all that talk for the last 15 minutes, and it just took a couple lines to implement. Yeah, normal mapping is one of those situations where it takes a whole lot longer to describe what's going on than to actually implement it. And there it is, folks. That's it. Now we can see our pillow texture sitting on our object. And really, that's all that there is to it. So thank you very much for your patience dealing with all of this crazy gobbledygook and all the monkeyness that kind of happened up until this point. All right, now that I've thrown a lot of stuff at you today, and really I haven't thrown much at you at all, but c'est la guerre. That's how things go in life, and that's what happens, and you know, live and let live. Oh well, that's what happens, but that's that's all that happens. Okay, let's get things going. And let me maybe move this forward. Okay. And okay, get rid of the global matrices here, and we're going to move this forward. Okay, you still with me? All right. Okay, we've got this going here. All right. Now, folks, we're going to continue our displacement mapping, I promise you. So next week is going to be the 3rd of September. Man, how time flies. Check in next Friday at 12:30 p.m. for the displacement mapping. Now, this lecture might be changed over again. It might get delayed again, but considering how many people that are actually tuning in and watching live, I don't think it's going to matter. So we might just actually have a pre-recorded element put into its place. All right, so that's what's going to happen next week. We're going to look at displacement mapping. It should actually be pretty short. It should only be maybe a 15-minute lecture at most. All right, folks, thank you very much for your patience for today's shenanigans. You know, what is an episode of TechArt Talk without shenanigans? I don't know. But anyways, go ahead, subscribe to us on YouTube. Go ahead and click that little button over on the right-hand corner and subscribe to this channel. Otherwise, you can go ahead and check me out. My name is Chris Hoda. I can be found on Facebook and on LinkedIn. Or you can check out TechArt EDU, which is also on Facebook and on LinkedIn. Or you can go once again to the techartedu.com website. Go ahead and check us out there. There's a little opt-in sign where you click on here, and then when you go ahead and click in here, I will be happy to go ahead and start sending you updates and announcements whenever we have some groovy stuff to pass on. Okay, gang. That's all that I really wanted to go over today. Thank you very much for your patience dealing with today's shenanigans and outrageous behavior. Tune in again next week when we will be going on to displacement mapping, which is kind of like the dumb cousin of normal mapping, but very important all the same. Thank you very much. I look forward to seeing you all again next weekend. Arrivederci.